Hello and welcome back to this tutorial series on full-text search across entities, episode 5. So far we created a Quarkus application, connected it to our Postgres database, set up a Pulsar cluster, and also running Debezium inside of this Pulsar cluster. Before we continue, just make sure that everything is working, because otherwise you might have strange problems. And as this setup is getting more complex, it's really important to make sure that you know which part of your application is working and which part is not working. So as you can see, I have the Quarkus application running. So it returns the JSON. And I also have the Pulsar cluster running. It prints out here some logging. And so I want to make sure that Debezium is still capturing all the changes on the database. Therefore, I'm going to log into the Pulsar service, and here I'm going to create a consumer that is listening for our book topic with some name. Okay, so the consumer is now listening for changes that we do on the book table, and I'm going to connect with PSQL to the Postgres database and just run some update. Doesn't really matter. You can even set the same value again. It will still count as a change. And yeah, this is the expected result. So you should see some JSON value here for the content part. I'm just going to copy that over so that we can see better how this payload actually looks. I'm just going to create a file called temp.json here and paste it in and apply some formatting so we can see the actual content. So depending on the log level that you have on your database, the before part will be null, but this is totally fine. Important is that we have at least the after part, and this has to contain all the columns from our database table, in this case the book table. It also contains some other stuff that is basically used for Debezium, where you can see basically more meta information about the table. But we're not interested in that. Only thing that is interesting for us, maybe later, is this ops part, which indicates which kind of operation happens. So there is U for update. It's also C for creating a new entry and D for deleting. Okay, so now we can start to actually listen for changes in our application. And before doing so, I want to clean up a bit the package structure. As you might remember, we created this web app package, and at the moment the author resource is under XYZ ghost letters, and I want to change that now. So I'm gonna change the view for a moment so that I can actually move this resource over in the web app where it belongs. Then I'm going to create a new package, and this one will be basically our search app. So if you would implement this search in the real world, I would highly recommend that you build an own Quarkus application or Spring Boot or whatever. I'm going to mix it up here in one Maven module, because that will make it easier for you to follow. But for real world app, I would really recommend that you build an own app and just share some domain classes with both of them. So I'm going to create another package, and we'll put all the Pulsar related stuff in there. We're going to follow again a bit the documentation on the official website of pulsar.apache.org. Just go to docs, and here you will find lots of documentation, and we are interested in the different client libraries. As you can see, they provide client libraries for different languages. We are interested in the Java part. And to be honest, this one part of the documentation of Pulsar that I did not like so much. It's still very easy to follow, but it only covers the most basic use cases, and this will cause some problems, but you will see that in a minute. So first we need the dependency, and I'm going to copy that over, just edit at the top again, and they nicely extracted the version into some property part, so make sure you also copy that over, or you replace the placeholder here. Just make sure that you have the version and reload it. And with that, we can actually start to implement our first Pulsar client. So a client Pulsar can actually be a consumer or a producer. We don't need a producer here because Debezium acts as a producer for us and puts stuff into the topic that we listen to. So we only need a consumer in our application. And actually going to create a new class called Pulsar subscriber. And this one will provide us with the client. So this method can actually throw an Pulsar client exception, but this is fine. We'll handle it. And when we continue in the example, it will actually show some code for the producer, but as I said, we don't need that actually. So I'm going to skip that over, and we continue at the consumer. And this is actually the code how we can use a client to create a consumer. So if we would replace this one, we basically would get a producer. And let's create another method. Actually returns a consumer. Make sure you have the correct import. And this will take as input a topic name. And again, I'm going to copy that over. And this will return our consumer, and the client will be derived by our init client method, which actually, as you remember, can throw an exception. So we're going to add an exception to the signature. Actually, I'm not going to need that this one is public, so I'm going to reduce it to a private method. Okay, so with that in place, we can actually, we have to use the topic name here. Otherwise, that would be surprising. The subscription name can be basically whatever you like. And now I'm going to implement one particular subscriber, while this one is a very generic provider of a not specified topic. I actually want to have a book subscriber. And this one should actually listen to all changes on books as soon as the application starts. So I'm going to create a method that listens for startup events, similar to what we did for the data seeder. And this one actually has to be managed by Quarkus. And this one now will use our Pulsar subscriber. And this class should actually know the topic name. So I'm going to create a topic name here. This is of type string, of course. And we actually need the topic name. So I'm going to kill this consumer and list again all the topics that we have. And this one is actually the one that we are interested in. So let's copy that over. And we're going to use it here. So now we have a consumer that is actually listening to all the changes that we receive in our Fuba public book topic. So here comes the part that I actually don't like so much. Even though they clearly state that it's just an example, they don't provide any different example. And here we have a while loop that actually never terminates because it will always be true. And this will, of course, some problem, which I will just showcase you. So let's restart the application. I'm actually going to add a second breakpoint here after the message received. And as you can see, the breakpoint worked. We are in the while loop that our application will never be able to get out of. And as you can see here, let me make that a little bit wider. We're actually in the main thread of the Quarkus application that is still starting up. So the startup of our application is not finished yet. And I let that continue. You see, we actually received already a message. And I'm going to remove that. And we continue to receive a bunch of messages because every time we start up, the database is created from scratch. So all these changes happening on the database are already catched by Debezium and forwarded by Pulsar to our application. So the first problem that we have is, okay, you just saw this message popping up here, but probably it was not so clear. So I'm gonna open terminal and I'm gonna do some changes on the database so that we can better see what actually happens. So I'm doing an update on the book table, and I would expect that this creates a new message that I see here. Let's clear that. So as you can see, the update on the database happened, but I don't get any message. So I add a breakpoint back here and do an update again. And this really almost drove me crazy. I see that the message actually was received and I run into a system out, but I don't see any message here. Okay, now I do, but I don't reliably do. Let's clear that again. And yeah, it's from the outside, it looks it looks like it's not working, or it's working randomly, or it's working very slow. And what actually happens is this printf, print format, is writing into a buffer. And this buffer is only cleared on a new line, and we don't have a new line. Or when some random thing in the compiler or at runtime thinks that now it's time to actually flush this buffer. You can look it up on Stack Overflow. And what makes it even weirder is I'm going to kill the application for a second just to showcase what madness is happening here. The solution that you find on top in actually Stack Overflow is, yeah, okay, you can just do a flush, but this is not going to fix it. And that really, as I already said, almost drove me crazy. So again, I would already expect here to see changes, but I don't. And yeah, we can look before, nothing here. I clear it. I do some updates. Oh, actually, okay, the table is empty, so my update statement does not work anymore. I'm gonna need an insert statement. I have one, yeah, here. Okay, this is some warning, but this is actually not the message that I'm looking for. So I'm still not at the point where I want to have it. And now the message shows up. Like really, it looks like it's super slow or random or broken or whatever. And the problem is that the terminals inside of the IDE for some reason behave different and don't respect this flush. This is also when you scroll down a bit on Stack Overflow, you can see people reporting that they have the same problem with Eclipse, with NetBeans. And now I can confirm, yeah, in IntelliJ you have it as well. So I don't know if it's interactive terminal or not. If I would start the application from a terminal like here, if I would run it, let's actually do it. Just to really show what I'm talking about. So I'm starting it from a normal terminal, whatever that means. And you see, these are already the messages that I was missing here. And let's create some space. And I do an update on the database. So here it is. And it instantly showed up here. So there was no delay, and the flush actually worked. If I would remove that flush, then again, this one would write into a buffer and it would not work. What you actually can do if you really want to use this printf as Pulsar does it in their official documentation, which I think is really not smart by them to do it that way. You can add a new line here. Okay, I'm gonna kill it in the terminal. So the application is back up and I'm gonna do an update. So let's create a new entry. And there it is. And you see now the message instantly shows up. I do an update and an update. And as you can see, all updates that I do here show up pretty much immediately here. Thanks to this new line, which causes the printf, the buffer that is inside of the printf to be flushed. Man, this is annoying. And just to save, I don't know what, millionth of a millisecond, really just go with a good old print new line if you want to use print anyway, which you shouldn't. But I understand that they do it for a Hello World example. They don't want to use a full-fledged log implementation that you might have not available. But for God's sake, please just use system out print new line. It's not beautiful, yeah, but at least it works in a reliable fashion. So one more time, I'm gonna restart the application. And we see these beautiful messages here already, which tell us that already the initial data was entered. The Dark Tower book, the It book, and then we have some more things because we create the author. And this will basically give us all that we ever asked for. Clear that one up. And here we see instantly beautiful update on our database reflected in our application. So with that settled, there is a problem that I mentioned with the while loop. And this problem you can see here. As I already mentioned several times, the application can never leave that while loop, which means the startup never finishes. And that means our REST endpoints and everything except this while loop is basically broken. And yeah, what I really missed a bit here was that they handled somehow how to continue from that basic example. And of course you can just say, okay, move all of this logic into an own thread and create a thread executor and I don't know what. But this is actually not required because Pulsar already comes with a method that will handle all of that stuff for you. And the only thing we need is to extend the creation of our consumer with a message listener. And I'm just gonna extend it here. So for this method, it's not interesting how the message listener is created. Just want to have one. Just like that. And the message listener basically is an implementation of what we want to do for a given message. And what we want to do actually is exactly the code here. So if we receive a message, we just want to get the data, create a string from it, and print it. If that works successfully, we're going to acknowledge the message. If it fails, we do a negative acknowledgement. So what we can do here is just create this message listener. And message listener is just an interface. So we have to implement it here. Actually, I'm just going to copy over this content. I'm just going to copy that over into our receive method. And going to rename that to message and remove this while loop. And that's it. That's already it. We just have to hand over the message listener and we're good. We can actually clean it up a bit and consume it, transform it into a lambda. Let's get rid of that. Yeah, it complains a bit because we lose all type safety and so on, but yeah, we don't really care. It's just to get started. And we will add type safety later. So let's start the application again. And as you can see, we receive the initial messages to create the initial data. And our REST endpoint is working again. And the final question, will we receive our updates? Let's clear that one up and do an update on the database, and there it is. So that's it basically. To wrap it up, we can now actually do changes on the database. And no matter if our application is calling the database or we call the database directly with an SQL query, we're gonna catch all the changes here. And we get this beautiful JSON, which contains the complete row that we changed. We could even get the state before if we want. And our application is working as before. And from here, basically, we can do with the data whatever we want. So in the next session, we are actually going to extract the data and pump it into Elasticsearch. So see you there.